Hey everyone, I thought I'd make a video. Some of you requested a more in-depth kind of walkthrough of how I customized my Savi lightsaber with a Neopixel blade and a Proffieboard. So I can I could change colors. It's got the nice red flicker. It's got a much more responsive swing, and you can change profiles on the fly. I'll go into depth in just a second, just kind of show you. You can quickly change colors. And I've got a little crystal housing in there. I'll kind of go through how I did that, but it's a very fun project. All right, here we go. When I started this project, I basically wanted to keep as much of the Savi's lightsaber as I could. The experience was really, really awesome, and I wanted to keep my lightsaber the same, including kind of the operation of it, being able to take it apart whenever I wanted to and put new pieces on. So that being said, all of the pieces can still unscrew. The end cap and the sleeves can still unscrew. The big difference is that I had to change the switch a little bit, and you'll see as I get into it what I mean. So if I unscrew the sleeves, I can get to the crystal housing and change the crystals out basically the same. Other than that, it's basically the same lightsaber apart from the electronics. I did have to 3D print a few parts for it. But other than that, it's a pretty straightforward project. So I ordered, this is a Neo Core, I believe it's called, but it's got the Proffieboard, and it's got a switch, a recharge port, and then this is basically the emitter contact, and speaker battery. Pretty awesome all-together piece. There's a lot of different websites that sell these, basically the same setup. This one costs, I think this one cost me about 120, and then the blade itself, which is a Neopixel blade, it's got brand new LEDs that run through it. These are much brighter and color changing, and it's got a little bit different end cap there. This one cost me about 80, so actually not too bad for the conversion itself. Well, probably about $200 total, and then obviously time. I did 3D print a piece for the blade itself. The inside of the Savi's is the same all the way down, except you can see just barely the contacts. And then I had to cut a little groove in the side of the 3D printed part. I probably could have drawn it in, but I totally forgot that there is actually a notch on the inside of the chassis to allow for the other one to slide in. So this one still slides in pretty good. And then I designed the top to look a little fun. But, and then other than that, I'll go into the chassis and inside bits. So this is the actual chassis that I had during the Savi's workshop. I ended up buying another one on eBay just in case I screwed this one up. But I'll kind of go into taking this thing apart a little bit. This is basically in, I would say, 1, 2, 3, 4, 5 different pieces. So there's the actual battery and speaker on the tail end. And then inside we've got more electronics. There's actually a black sleeve on the inside of this part that has some of the electronics. It's some of the circuit board. There's, I think, the accelerometer is in that section. And then on the top end, the plunger end has, I believe the RFID reader is on this end, and then the contacts for the blade are also on this end. But you can see the black sleeve on this end obviously coming out. There's another one on this side that looks similar. It's just a little bit shorter. And then when I bought the Neo Core, I knew immediately that if I was going to keep this crystal housing, that I was going to have to adjust or extend the electronics in some way. So basically what I did was I took this section, the battery, speaker, and circuitry, All of that fits pretty nicely in the tail end of the Savi's chassis. The switch itself, I had to run through the side of the, and I actually had to cut a notch here in the Savi's chassis to run the wires through, and I can show that in just a sec. And then on the top end, I had to pull out, you might be able to, somebody out there is probably smarter than me and is able to probably figure out a clever way of making this top part of the chassis work. The blade itself is actually the same thickness as the Savi's blades. The Neopixel, in my case, is just a little bit longer. It's a 36-inch instead of a 31, or yeah, I think it comes with a 31 in the Savi's workshop. But other than that, I took this black section out as well. But I cut the black section and plunger where the contacts are for the crystal. I left all of that in there just because it works nicely with how the crystals are pointed. And yeah, other than that, I didn't have to extend or resolder anything as far as the board goes. The cabling that runs from the end of the Neopixel actually does make it to about this section in the chassis. So it actually does fit together pretty nicely. You can kind of see lining up. It's pretty close. But I did have to run the cabling through. So if you can see the inside right there, there's like a little notched section there. When you unscrew these and pull these out, when you get down to it, you can actually slide that piece of plastic in and out, and that's what covers up. There's wires that run from the the power section of the chassis up to the what is the emitter section, what actually powers the rest of the blade. And the way they hid that was through that little plastic piece in there that does slide in and out. I did have to do a fair amount of cutting of the black pieces in order to get things to fit properly. But that's kind of a quick explanation of the chassis conversion. With this section, I ended up just lopping off this piece of plastic, leaving the battery housing and circuit housing all together, and then taking the switch out. So when I take apart, I'll just go ahead and unscrew these pieces here so you can kind of see better what I did. Again, I wanted to keep as much of it the same as I could. But you can see that when I pull this off, the crystal and everything is still basically the same. But the wiring on the inside runs through a little notch that I cut in the side. This is a pretty beefy plastic, and I noticed that it also takes threading really well. So when it came to reassembling, I did drill a few places in. So for example, for the crystal, to hold the crystal in place, on one section it's spring-loaded, on the other section it's actually solid in the original chassis. So I just drilled out and then rethreaded a few pieces in to keep this one solid. And then on this section, these screws actually screw right back into place of the black piece that I ended up cutting off. You can see, if I go real close, you can see where the 3D printed section starts, and then where the piece that I kept in there is still there. I ended up pulling the plastic, even though I really liked them, the plastic pieces out of there, the little windows, because I am still probably going to go in and fiddle with it a little bit. The next part I ended up doing was I could rescrew this in and it was pretty solid, and then I had to rethread these ones because there actually wasn't enough threading on the tail end for these screws to go back into place. I ended up having to drill out and rethread. So for this project, a tap and die kit is pretty useful if you're going to do something similar to me. That's at least what I used. So, reassembly and everything is the same. The other thing that I did was I ran an LED on either side. So the original one does have an LED in, I think it's the bottom end, but I ended up running, there's holes on the top and bottom of the crystal holder, and I put an LED facing in towards the crystal on both sides so that when I power it up, you can see the color of the crystal in there. But other than that, that's basically it. As far as the battery and speaker, I did print a little piece to keep it kind of in place, but essentially this whole piece is just the tail end here with a little collar that I printed on top of it to keep it from wobbling around in there. And actually, it fits pretty good. It doesn't move at all once I get the collar in place. And then I can reassemble exactly how you would. As far as the blade goes, the blade is a little bit more intricate, only in that I had to print a piece to hug the blade. Other people have just drilled it out and tapped out, put a couple of set screws in to hold the blade in place. Like I said, you might be able to keep that black part in from the original chassis, figure out a clever way of doing it. I basically didn't want to do it. One thing to note, you can kind of just barely see it, but there is a white collar that I 3D printed to keep the top piece in place. Now when you get these ones, this is much thinner, you can kind of see, than the actual inside of the chassis plastic. So I ended up having to 3D print a collar that kept the contacts in place from wobbling around. The contacts are rather delicate, and I wanted to make sure that they wouldn't move around at all when I'm trying to put the blade into place. And then, yeah, like I said, 3D printed a little collar piece that hugs the inside of the blade. And then when I actually lock it in place, there's 2 more set screws that I put into the side. Again, I drilled them out, used a tap to create new threads into the metal, and then I can find the groove on the inside so that it locks in place, and then I can screw these down, which actually locks on top. You can also go through and then actually make contact with the blade, which might be even a little bit more sturdy. You can tell I'm still kind of futzing with the switch piece here. When I bought this kit in particular, the switch is pretty long. They have tons of different switches and probably different recharge ports that you can look into. I just liked how this one was set up, but I did have to drill out a section here so that the switch could fit through. With this piece in particular, there was no real space for those switches to kind of fit through the inside. So I had to cut a section out of it. And then I'm still 3D printing and designing this piece to kind of match my design so that it covers up the hole that I made on the crystal or the switch housing. But yeah, that's basically the whole project. It's a 3D printer for me was pretty necessary. You might be able to get away with if you're a pretty clever machinist, but it's not that hard. I think that the difference is quite stunning as far as the color and brightness for these different profiles. And you can design your own profiles with the Proffieboard. You know, it's actually pretty amazing. So yeah, if you have any questions, just hit me up on Reddit, and I'll be happy to answer them. Thank you so much for watching.